Hello, Mandela United. It's Wednesday, April 23rd. Oh, it's Thursday already. I take that back. We're going to talk a little bit about Tinkercad today. Specifically, we're going to talk about Tinkercad as it pertains to reviewing Arduino. And I know a few of you in Intermediate Advanced have asked for a bit of a refresher on how Arduino works. So over the next couple days, I'm going to make sure these things get up here so that you can kind of review what you probably learned in a past year but may not have remembered. There's nothing wrong with that. Just if, before we get started, you want to follow along, there's a few things that I do have open here. One of them is the Tinkercad interface itself. I've logged into my account at this point. And I also have open a couple of Arduino windows. Now, I'm going to be doing the actual Arduino code editing in the Arduino IDE. That's the Arduino app. You can download this for free if you're working on your home computer. It's at arduino.cc, or can be found in the Windows Store as well at this point. I've popped the text size up as big as I can here to make sure that everybody can see it, but I'll be talking through every piece of it as best I can throughout the course of this. Right now, I've gone to File Examples. And under Basics, I've opened up two different pieces of code. The first is called Blink, the second is called DigitalReadSerial. Today we're going to talk about how to make an LED turn on and off, we're going to talk about how to make a push button work, and those two things are kind of foundational to make most of this stuff work. We'll talk about the other more advanced things in another video at another time. So, now that I'm back in Tinkercad, if I click here on my Circuits button, I'm going to get into my circuit editor. Now I've got the tremendous Megalio Coupe. I'm going to go tinker this because it's some stuff that I've already put together, and it's something that you can actually follow along with if you'd like to. And I'm going to rename it first to say LED and push button demo. Cool. Now, I'm going to walk you through what I've actually already hooked up here, and it's somewhat simple. So if we've got our Arduino here, you've got your digital pins on this side, which includes a ground and a few other things. And then on the other side here, we've got our analog pins as well as our basic power pins here. This is our 5 volt and our ground. It's about the only piece that we've used at this point because it's going to help power our button and our Arduino. We've then run those wires, again, red for positive, black for negative, ground in this case, and we've run them into our power strips, okay? Our power rails. And our power rails on our breadboard, as you can see, are electrically connected the whole way across. This is important because it gives us lots of points of contact to actually hook into. We've also jumped, meaning we've run a jumper wire across our breadboard to make sure that our power rails on this side are also connected. This means, and you can see we've done this with the LED, we can actually connect the LED to ground or negative via this side of the board. Now, a couple things to put together, a couple things to make work. We're first going to focus on the LED, which I often refer to as a digital write. This means we are going to be sending information out. That's the write piece. The digital piece refers to the fact that an LED, in this case, is going to only have two states. It's going to have on or off. It's going to have high or low. It's going to have 1 or 0. And I say it that way because those three things are all synonymous to one another. They are all exactly the same. When you tell the Arduino to send a high signal, it's going to send a number 1, a on signal, or a 5 volts. Those are all pretty much the same thing when it comes to digital signals. And keep in mind, digital signals are always on or off. They only have those two settings. We'll talk about analog another day. When we zoom in, we've hooked up our LED circuit. And what you notice right away is that this LED actually is connected on one side to ground. It's connected through our terminal strip here into a resistor, in this case a 1000 ohm resistor, and it goes through the LED, and then the LED in line 16 here, in terminal strip 16, is actually connected over to pin 13. Easy. Now, in this case, if we're using this in Tinkercad, 1000 ohm resistor, that was a little distracting, 1000 ohm resistor is just fine. However, in reality, if you're doing this in real life, the 1000 ohm resistor will barely light up for most LEDs. I much prefer a 470 ohm resistor, okay? That's our yellow, purple, brown, if any of you remember your resistor color codes. Now, given this, we need to find out what code is in this Arduino if we want to make this LED work, and this is where this gets interesting. I'm going to pop open my code editor, and I'm going to realize that I have something else going on in here. It was from a previous project, so I'm going to go over to my Blink code, and I'm going to see, I think this is somewhat visible, but just in case, I'm going to go to my preferences, and I'm going to actually pop this up to about a 32-point font. Okay, that way everybody can see what we're actually talking about here. Now, the things you need to know in code. Basics, bare bones basics. Anything that happens with a dash and a star in front of it, like the start of blink, and ends with a dash and star, everything between those two symbols is going to be commented out. You notice that it turns gray. Anything in gray, the Arduino doesn't care about. It's purely communication for the human element. The machine will not compile it, the machine will not put it on the Arduino, it will not turn it to machine code. None of that happens in that order, but regardless, this is something where this is all going to be just to communicate what's going on. This is things like crediting who wrote and edited this. It's talking about how to hook up the circuit it needs. And right now we can see it's going to turn an LED on and off for 1 second. It's got an onboard LED, but we can also use digital pin 13, which is exactly what we've done on our board. We're going to float down and we're going to read this code. Now, lucky for us, this code is exceptionally easy. The first thing it starts out with is a double slash. This is the same thing as commenting out a code as before, but all it does is comment out things to the right of that symbol. This tells us the setup function runs once when we press reset or power the board. This is as opposed to our loop function, which we have down here, which is going to run over and over again and just keep iterating until the batteries run out or there's an end function. In this case, our setup starts with this curly bracket, and you can see that it's actually highlighted this curly bracket down here. And that's a good thing. Everything inside of these two brackets is going to happen once. And as you can see, whoever put this code together has commented on it exceptionally well. It says it initializes a digital pin LED built in as an output. Now we're going to mess around with this a little bit because the board, the Arduino, has a built-in LED. It's the one on the board. If we look here and we zoom in on our Arduino, it's actually that guy right there, the letter L. Now, we're not going to use that one. We're actually going to use the external LED that we put on, and we put it on pin 13. So we're actually going to type in the number 13 here. It's going to get us a good start. Now, we're going to set it as an output. Now, if I ever get to a point in this Arduino journey that I don't know what a command does, let's say I don't know what pin mode does, I can kind of see it here. I can see that it sets this as an output, but I'm not quite sure what it means. If I right-click on this command and I click Find in Reference, I'm actually going to be given an Arduino reference page. And this is going to go through some of the specifics of how each piece works. So this says that pin mode, configures the specified pin to behave either as an input or an output. Okay, it'll actually talk about digital pins if you want to go very much in detail. But what we really need to know is that the syntax is pin mode, round bracket, pin comma mode. The pin is the number of the pin who you wish to set. In this case, we picked 13 because that's what we wanted to do. The mode is going to be either input, output, or input pull-up. We're not going to worry about input pull-up right now, but if you want to read up on that one, you are more than welcome to do that. In this case, we're just going to be playing with inputs and outputs. In layman's terms, an input is going to set internal resistance on the board so that it's expecting a sensor. It's expecting something that has really low amounts of electricity running through it, or it's expecting it to be really specific with something like that. An output, which is what we're dealing with now, is expecting a fair bit more voltage or amperage to go through that particular pin. And that, all told, is going to give us what we need to do. So we're going to go back to our Arduino window here, and we're going to know that we've got pin 13 set as an output. If we go down to our loop, everything between these brackets is going to run forever, or forever within reason. And that's good because what we really want this to do is turn the LED on and off every second. Now right now we have DigitalWrite. I'm just going to move to my preferences and turn my line numbers on because that helps. Okay, this is on line 33 right now. We're actually going to take a DigitalWrite and we're going to DigitalWrite. We again don't want the LED built in. We want pin 13 and we are going to DigitalWrite high. Now DigitalWrite is simply turning that pin on or off. That's all it does. And it only has two choices. It has high or low. We could also read this as a 1 or a 0 if we wanted to, if we're using binary for this, but high is the usual way to do it. Now one thing I haven't pointed out before this point is this semicolon. Remember that if you're programming this, that semicolon acts as a punctuation. It's kind of like anything in English. If you finish a sentence, you're going to end it with a period, an exclamation mark, or a question mark, or something more esoteric if you're a language nerd. And in this case, this says that yes, this semicolon says that this command is done. you can go on to the next one, Arduino. Go look at whatever's on the next line. You'll notice that it happens on every discrete command. The only ones it doesn't happen on are our loops. And anything that is a piece of control flow, which includes your loops, which includes things like if statements, while statements, they won't have semicolons. But that's about it. Everything else should finish with a semicolon. And you'll notice if I delete one of these, let's say I take away this semicolon at the end, and I try to compile this code, I'm actually going to be given a big red angry screen, and I'm going to be given an error. If we look at this error, it says expect the semicolon before the next line or before the next command. And it actually identifies it. It highlights that line. So, oops, put the wrong semicolon in. There we go. Let's move our way down. Line 34 says delay 1000. We said that we wanted this to go on and off every 1 second. You could probably use some logic here to deduct that this means that the 1000 is representing milliseconds. So we actually are going to delay for 1000 milliseconds or 1 second. Then, and while this is being delayed, it's keeping the state of whatever that LED was. So it's going to stay on for this 1 second. Then on line 35, we're going to take that pin 13 and we're going to make it low. We're going to make it turn off. So let's see if this code works. Let's grab the entirety of it. I'm just going to grab the part that's going to run here, and I'm going to press copy and go back to Tinkercad. I'm going to select everything here, and I'm going to press paste. Now, this should, if all is right with the world, close my code editor down. I'm actually also probably going to go ahead and move over here. There we go. We're going to take a look. When we press start simulation, we're going to see an LED that turns on and off every second. You'll notice that the built-in LED over here also turns off every 1 second. And those two things are kind of connected electrically on the board. But that tells us that we have a functional LED. Now, let's make our code a little better. Before we edit code, we have to actually stop our simulation. And I'm just going to go back and show you one cool trick, because it's going to help us in the next piece of code we're going to do. If I go back here to my blink command, and I'm going to re-verify it because I've re-added that semicolon. It's a good idea to verify your code before you push it to an actual Arduino. Notice that it actually gives me the screen that says, yep, we compiled this properly, we're good. I'm going to actually make this easier because when we went through here to change that LED built in to pin 13, we actually had to go through 3 steps, and that's not very efficient because if I want to change my LED again, I have to change this 13 in 3 places. Now, this being the basic hello world of the robotics world, excuse me, that's okay. There's only 3 spots, but wouldn't it be easier if we could do it once? To do that, we're going to use a variable. Now this is going to add a 3rd working space to what you're doing in your code. This space is going to actually go before your setup or your loop because we are going to set up a variable, in this case a global variable, and we're going to make it so that it is equal to the LED. We're actually going to make a variable or a word to represent that pin. In this case, we are going to use int. Int means integer. It is meaning we are creating a variable that is going to store a number. We now need to name our integer. In this case, we're going to name it LED. And keep it simple on this one. All right, and then we are going to give that integer a value by making it equal to. My keyboard seems to be having a moment here. Hang tight for a moment. I think I might be set to a incorrect keyboard setting here. All right. Maybe I'm just having a moment. There we go. Okay, keyboard was set slightly wrong. That happens. Okay, we're going to make the LED equal to the number 13. Now what this means is that we can actually go back through our code, after putting a semicolon on here, of course, and we can actually replace all of these number 13s with an LED. Now why the heck would we do that? This isn't as efficient. I just used 3 letters where 2 numbers would do. But what it means is that if we wanted to change where our LED was on this circuit, it would be relatively easy. Let's say, for example, we wanted to move our LED to pin number 5. All we do is we change the integer to LED number 5, grab our code again, and I'm going to go back to Tinkercad. I'm just going to go back to my code. I'm going to paste that new code. Notice that LED is now an integer. It is equal to 5, and it shows up in 3 places. Now, in a piece of code where you're writing hundreds of lines of code, this is hugely efficient. If I have to change hardware somewhere, I don't have to change everything. Now that lets us actually take our LED and actually move it over to pin 5. I'm going to keep my nice straight 90-degree angle lines and start our simulation. LED still functions. Life is good. Notice as well that the onboard LED over here on the board doesn't turn on anymore because it was wired into pin 13, not pin 5. It's just a bit of collateral damage there as it was. I'm going to stop this simulation and we're going to go onto the push button. Now, how does a push button work? Push buttons are relatively simple. If we float over our push button, we realize that we have 4 terminals. We have terminal 1A, 1B, 2A, and 2B. And what that means is that this side of the push button is normally electrically connected. How could we test that out? Is there a way we could test that out? Let's try it. Let's take a push button and let's see if those sides are normally electrically connected. We're going to take an LED. We're going to connect the negative end of the LED to negative. Okay. We're then going to take the push button. We're going to connect the positive end of the push button to positive voltage. What should happen here is if the push button is electrically connected, it's going to, if terminal 1B and 1A are normally electrically connected, that LED is going to turn on. As a matter of fact, that LED is going to explode because as we float over it, we realize that it actually has exceeded its rated amperage. In this case, we get almost 500 milliamps, whereas the LED was really only rated for 20. Oops, LED doesn't work anymore. Throw it in the garbage, start a new one. But what that does prove to us is that this circuit is normally connected. Now let's compare that to the 1A and 1B to one of the 2s. Let's connect this over to positive voltage on 2A. In this case, when I start my simulation, the LED does not turn on. Clearly the simulation's still working because my blink is still running over here. But when I push this button, you got it, LED explodes. And by the way, when you let go of the push button in real life, the LED doesn't put itself back together again and keep working. You throw it in the trash because it's burned out. But this shows us what happens with this push button. Normally, 1B and 1A are connected to each other. 2B and 2A are connected to each other, but it's only when I push the push button in the middle that they all become electrically connected. Now, how the heck can we do that? Use that with an Arduino? We're going to set up a really easy circuit here to make this happen. In this case, we've got our pull-down resistor here, and what we've done is we've connected 3 things. To terminal 1A and 1B, we've connected the Arduino, pin 2. We've connected a large resistor, in this case 10,000 ohms. The larger the better in this one. Because really we're just trying to complete an electrical circuit that does something very funny here when we get moving. We've connected this to our ground or our negative wire. Now, on the other side, terminal 2A, we have 5 volts. Now how this works is that normally we are going to go ahead and read what's happening on pin number 2. And in doing that, it is going to normally read whatever's coming through terminal 1A. In this case, a connection to ground. Now in digital terms, we said that 1 was on, 0 was off. 5 volts was on, 0 volts was off. In this case, the pin is actually going to be reading 0 volts, which is what we want. We want it to look like it's off. Now, when we push this push button, something funny is going to happen. We actually are going to allow 5 volts to flow through this circuit to this pin. But it also is going to flow some electricity down into here. But because we know what happens with something like Kirchhoff's laws, we actually know that the voltage or amperage split between these two is going to mean much more electricity is going to be running through number 2 than it is back to ground. This is going to cause our pin to read high, or 5 volts coming through it. Now, how do we do that with code, though? Let's go back to our Arduino app. We got another one. This one's called DigitalReadSerial. Now, let's decode this. As we did before, we were able to open this up. We were able to say what happens here. Reads a digital input on pin 2 and prints the result to the serial monitor. Now, the serial monitor is something really interesting. When you connect an Arduino to your computer, you connect it via USB. A USB has 4 wires in it. 2 of them power the Arduino. The other 2 are where the data is exchanged. And the method your Arduino uses to exchange data is called a serial connection. Serial connection very simply means that the data is going to come in a bunch of zeros and ones, highs and lows. It seems like a theme here, actually. And what that means is that that serial communication is going to allow you to exchange data. You can exchange zeros and ones to represent letters, numbers, really whatever you want, which is how you upload to your Arduino. It's also how we're going to talk to the Arduino. So let's go down here. In our space before our setup where we declare variables, we've got one variable right now. We've called it int push button. So it's an integer variable, again, number based, and it is a push button. Notice that we've capitalized the letter B in the middle of this. This is what's called camel case. Camel case means that when we write a word, we are going to use a lowercase first letter, but every word that goes after that, we are going to use an uppercase letter. Variable names don't recognize spaces. If I put a space in the middle of this push button, it's going to try to read it as two separate variables, and it's going to throw a big error. We don't really want that. We're going to make our push button equal to 2, and this is exactly what we did before with our LED. We declared the LED as a variable name so we wouldn't have to rewrite it. In this case, push button shows up a couple of times in our code, and we don't want to be messing with all of those number 2s. Let's go down to our setup. Now, in the case of this, our setup is going to use one new command that we haven't seen before. That is serial.begin 9600. This is what's actually going to open up the serial communication with the computer. And it is going to allow the Arduino to know, yes, I intend on talking to my Arduino board using the serial monitor. Serial monitor is going to be a screen where we can see what's happening there. In this case, we use a pin mode, and we set our push button to input. And input in this case just means that we're going to be using it as a sensor. I think we talked about that before. Let's go down to the bottom here. We go down to our loop, okay, we're going to do a couple things. The very first is we're going to use a new command called DigitalRead. Now, you know what a DigitalWrite does. It sends voltage out. It turns something on or off. A DigitalRead is the exact opposite. It asks a question and says, is this thing on or off? Does it get voltage or does it get no voltage? And in this case, we're asking the question, does the push button get voltage? Since it's digital, this information is going to come back as a numeric 1 on, or 0 off. And that is going to be hugely useful to us because the ability to turn a physical instance of like a pushing a button or a physical action into computer code is kind of the basis of everything we do in robotics. This is the holy grail right here in terms of making stuff happen. Now, in this case, we've actually created a new variable. Every time you put the letters int before a variable, you are creating that variable. In this case, we've got a local variable, whereas the variable up here, push button, it exists for this entire code. This variable down here, button state, only exists inside the void loop. It only exists down here. So be careful. If you intend on using a variable throughout your code all over the place, you may want to put it up at the top. In this case, we're only going to be using this for a brief millisecond. We create a new variable called button state, and we make that button state equal to whatever number we're using with DigitalRead. This is like creating a bucket. We make a bucket and we named it button state. We wrote it right there on the bucket. And then we take and we find out what's happening on this one switch, and we put that information in the bucket. We can put that on the shelf. We can store it. We can actually do something with that memory that's going to make us able to use it. Let's go down a couple lines. What we're doing now is we're using what's called a serial print, and that is an LN. It's not an IN. It means new line. And we're going to actually print the value of button state. Every time line 27 happens, Arduino simply goes up to that shelf, pulls that bucket down, looks at it, yep, it's called button state, and goes in and says, what's inside? And what's inside should be whatever came off of this DigitalRead command. And that's going to allow us to actually print out what's happening on that button at any given time. Let's try it out. I'm going to grab the code that matters here. I'm going to go back to Tinkercad. And again, I've got my push button circuit here. Let's go to our code, highlight all of our code we had, and paste our new code. Now, I'm just going to move some stuff out of the way here so we can see what we're doing. There's our circuit, there's our code. Let's start our simulation. Now, right now nothing's happening. Clearly, push my button, nothing happens. We look up here, nothing happens. It's because we're not looking at our serial monitor yet. It's down here at the bottom. When I click this, I'm going to get a series of zeros. And that makes sense because right now, this pin here, number 2, is reading 0. It's reading ground. It's coming in off of this resistor. But as soon as I press that button, I'm going to get the number 1. And when I let it go, I can see all versions of this, 0s and 1s, to see when the button is pushed. Because every time I push this button, it allows 5 volts through into the digital pin. And this is the basis of sensor control in everything we do with Arduino. That's all I've got for you right now. I hope that gets you the basics of DigitalRead and DigitalWrite and gets you an idea of how the Arduino functions to bring information from the real world into the realm of a microprocessor or microcontroller in this case, and actually turn our real world digital. Cheers. Hope you enjoyed this, and we'll see you for the next video.